Scratch is a 2D programming language that has its users wondering if there will ever be a 3D mode or even a VR mode in the future. Even though both of these have been rejected, it still hasn't stopped Scratchers from making 3D games in Scratch. So, if it hasn't stopped 3D games from being made, is it possible to make VR in Scratch? In the last devlog, we got to work making a VR game in Scratch, but we ended with two important components missing in our game: controllers and headset rotation. And oh my goodness, you guys have given tons of suggestions on how to make this work. In this video, we won't be working on the actual game, but instead on your suggestions to make rotation and controllers in Scratch work. So, without further ado, let's continue our attempt to make a VR game in Scratch. Oh. There is one thing though we need to address right off the bat. So at the end of my last video, I teased using some form of modding to add headset rotation to our VR game. The problem is, if you make a game in modified Scratch, does that mean you're still making a game in Scratch? In other words, if I say I'm making a game in Scratch, does that mean I can use Scratch mods such as Turbo Warp? From your thoughts, it seemed to be a split decision. Some of you wanted me to switch over to modded Scratch sooner rather than later, while others of you say that Scratch only counts if it's native Scratch. The problem is that each of these paths has its pros and cons. So which path do we take? Well, why not both? If we make a VR game in both native Scratch and modded Scratch, we can enjoy the benefits of actually making VR in Scratch, while also requiring only minimum hardware for players to enjoy the game, as well as the ability to provide some features that Scratch doesn't provide. So, with that out of the way, let's get started. The first thing on our list is to get the physical rotation of our head in native Scratch. Now, there are several ways to make this work, many of which come from these extensions that Scratch has provided for us. In the last video, I talked about the Go Direct Force and Acceleration extension, and how we can get the rotation of the headset through this device. Now, many of you wondered why I solely focused on this extension, when there are several other extensions that can also get rotation. Some of you mentioned about the microbit, for example. Now, some of these comments were about using it as a controller, but others were about using it to track rotation, as it's much cheaper than Go Direct. The reason, though, why I focused solely on Go Direct Force and Acceleration was because of a concept we should cover, called degrees of freedom, which I learned from you. You see, VR headsets have either 3 degrees of freedom, which track rotation in 3 axes, or 6 degrees of freedom, which track not only the 3 axes of rotation, but also position. Most modern headsets fall under the second category, but getting 3 degrees of freedom in native Scratch is already a challenge. So that's our current goal. Now here's the weird thing. For every hardware extension capable of measuring rotation in Scratch, Scratch will only give you the rotation for 2 axes, which is less than our goal of 3 degrees of freedom. This is weird, because some of the extensions have the capability of measuring in 3 axes, but whether it be for the sake of simplicity, consistency, or some other reason, Scratch only gives us 4 directions to work with, and as far as I know, 2 of these are just the negatives of the other, resulting in 2 axes. The only exception though is Go Direct Force and Acceleration, which technically still gives us the same default options for rotation. Unlike the other options though, it gives us the spin speed in 3 directions, which can be used to calculate the rotation of the missing direction. However, as useful as this extension might be, it's very expensive, and in relation to other Scratch extensions, harder to get your hands on. So even if I were to get this tool, it wouldn't be accessible to many other Scratchers who would want to play the project. So for now, we will not be using the Go Direct Force and Acceleration extension. However, this makes finding a way to get 3 degrees of freedom in native Scratch much harder. To increase the irony, the only hardware extensions I had were the EV3 and the Makey Makey, which are the only 2 hardware extensions that don't get rotation in Scratch. Or can they? You see, Scratch doesn't have a block that gets an EV3's rotation, which is weird because EV3 has gyro sensors which are capable of measuring rotation. However, Scratch does measure the rotation of any motors connected to the EV3. So here's my idea. We can attach 3 gyro sensors and 3 motors to the EV3. Write a program in the EV3 IDE to rotate these motors to match the gyro sensors values, and then get the motors values in Scratch, which will reflect the values of the gyro sensors. And my friends, this works terribly. I can't tell what's happening right now. This is awesomely terrible. No, please go that way, please go that way, please go that way. Yes, go that way, go that way. No. I'm guessing that something about going from hardware to software again just creates many potential problems. But hey, at least we had 3 degrees of freedom in native Scratch. Kinda. I'm not satisfied. As I was thinking about it, and also trying to get rotation in modded Scratch, I realized that maybe 3 degrees of freedom isn't entirely necessary. While rotating your head left, right, up, and down is common when looking around, rotating side to side isn't. So I gave in and bought a microbit. Now, first day of using the microbit, I learned 3 things. 1, this thing is very tiny. 2, it's really easy to get an error code on this thing the first time you use it. And 3, I don't know how to unbox something on camera, cut the camera. Now, in order to connect Scratch with the microbit, you need to flash this hex file onto the microbit, which enables it to connect with Scratch. The first time I tried this, I got this weird error code called GEPEV. I couldn't find anything on the web about it, and after a few tries and quite a few error codes, I realized that it had worked the first time I tried, and that GEPEV was just the name of my microbit. Ready for pairing with Scratch. Now, can we get the rotation of the microbit in Scratch? Yes, but it's very confusing. The front-back rotation is pretty straightforward, but the left and right is kind of confusing. It feels like this rotation affects the output, but so does this rotation. And when you hold the microbit this way, the 2 rotations swap? I'm very confused. It's very confusing. I was able to get it to work once, but we do still have a few problems then. Mainly that the microbit's output of rotation is very shaky. So we would need a way within Scratch to detect which movement is real and what's not. That all being said, I don't think the microbit is the best candidate for getting headset rotation. The output is a little shaky, and getting the headset yaw is too confusing. Therefore, I won't be using the microbit for now. Unfortunately, we're starting to run out of options. Other options, such as Boost and WeDo, can still get rotation, but I do want this game to be easily accessible for anyone to play without a huge price. And these extensions are much pricier to get your hands on. So we're now stuck trying to figure out, oh, I got a notification. You should check out this Scratch VR. This is Underpick, who has also made a VR game. In my initial research for this series, I saw their Fisher VR game, but I originally ignored it because it wasn't true 2-screen VR. However, they also have made a 2-screen VR demo, complete with getting headset rotation. It doesn't require any special extensions. All you need is a phone. How they do it is absolutely genius. But if you want to know more about it, you're gonna have to check it out for yourself, as it is extremely crazy how they made this work. The only hint I'll give though is that it utilizes the video sensing extension. However, there seems to be one small problem, and that is that, for some reason, I couldn't get this to work on the iPhone. In this case, I was experiencing a bug or glitch where the video would immediately freeze after turning it on, making its sensing blocks unusable. I filed my findings on the bugs and glitches forum, but as of this recording, I still haven't been able to get it working on an iPhone. But Android does correctly support video sensing. Unfortunately, the engine didn't work straight out of the box, probably due to the fact that I was using it in a different way the engine was designed for. However, with a few minor tweaks, I was able to get it to work. Of course, using video sensing to get rotation will result in some problems. For example, drift and inaccurately measuring rotation. We can try to mess with these values to abate these issues, but I think that the best way to deal with them is to build our VR game around them. Even with these problems though, I think that this is the best method by far, considering that this works on any phone. Well, almost any phone. Therefore, with Underpig's VR engine in hand, we have now tackled getting rotation in native Scratch. Woo! With native Scratch out of the way, we can now discuss getting the rotation in modded Scratch. Now, at the end of the last video, we discussed that since there wasn't good support for getting the rotation on iPhone, we would have to resort to modding Scratch ourselves. However, many of you guys mentioned that there are other extensions out there that can help us. Well, ladies and gentlemen, you saved me a lot of time. So some of you mentioned that there was a VR extension in the works. After some searching, I managed to find it on Snail IDE, another popular Scratch mod. Rather than using a phone, this communicates directly with your VR headset. But there's just one small problem, and this is gonna be crazy. So I don't know if you noticed, but if you pause the first devlog right here, yeah, I don't really have a VR headset. Yeah? I know, this is crazy, but in some cases, I don't really have a context for traditional VR, except for maybe once when I tried a VR headset from a friend. twice if you count a VR app on iPhone. And now I'm trying to make a VR game in Scratch. Oh my goodness. Now, in terms of using actual VR or implementing it with a phone, I think we should go the phone route. Besides, if we implement Scratch VR for phones rather than actual VR headsets, anyone with a phone can play it as long as they have a phone-based headset, which isn't that hard to get or even print. So, we're going to need a way to get the phone's rotation in modded Scratch. And this is actually quite easy. You see, in the last video, we tried using TurboWarp's AR extension, which wouldn't work on an iPhone. However, apparently I overlooked TurboWarp's other extensions. Many of you guys mentioned about an extension titled Sensing Plus. If you scroll down to the very bottom, this extension has two reporter blocks, one which gets the phone rotation and another that gets its acceleration. This is extremely cool, as this allows us to get 3 degrees of freedom and hypothetically 6 degrees of freedom within modded Scratch. There is one question. Does this work on my very old iPhone? I'm actually really surprised none of you mentioned how old this thing is. This is an iPhone 6S, oh my goodness. Well, it does work. Look at that. We're now able to get an iPhone's rotation in modded Scratch. All we have to do is implement this into our VR game. This actually turned out to be somewhat difficult. Apparently, when you tilt your phone up and down above a 0-degree angle, 2 angles just suddenly flip their values, so I had to figure out what was happening and then account for it in the VR game. But after many attempts and 10 different versions of V3, I was able to correctly implement all 3 axes into our VR game. Well, almost. The roll axis, which is simply rotating the phone, is kind of broken, but I'm not going to worry about it since if you rotate your phone too much anyway, it flips your screen over because unfortunately, we don't have horizontal rotation lock. And there we go, all 3 degrees of freedom in modded Scratch. We can try experimenting with device acceleration for 6, but I want to make a game that can be playable in both vanilla and modded Scratch. And since we don't have a good way of getting device position in native Scratch, we'll just stick with 3. With all that said, we have successfully implemented rotation. The only obstacle left into adding VR functionality is controllers. Originally, I ignored controllers because I assumed it would be impossible to implement fully in Scratch, which is still kind of true. The biggest problem with controllers is that they have 6 degrees of freedom. Not only that, but native Scratch doesn't support any controllers, other than your basic keyboard and mouse as well as a touchscreen. However, many of you guys had some awesome ideas, so many that controllers eventually became hard to ignore. So, let's jump right in. So here's one idea, which was awesome. Instead of relying on actual controllers, this uses a special trick. This trick is to have 2 phones, one acting as a headset and one as a controller. The controller then sends information to the headset via cloud variables. This information can be screen presses or whether the phone was being shaken via video sensing, allowing the phone to act as a controller communicating with the headset. This quickly became a popular idea. However, there are 2 considerations we'll have to make. First, Scratch's cloud variables have been broken for a little while now, so we'll have to do this through TurboWarp. Second, there is a bit of lag between cloud variables, so there will be some input delay. However, for our purposes, this is the best solution. Now, for our TurboWarp users out there is a more advanced version of cloud variables called CloudLink. However, this project is discontinued and I got errors when trying to run the demo server. Now, a lot of you mentioned that we can get 2 buttons and some other inputs, such as shakiness, through a different controller of sorts. The good old microbit. At first, I originally wanted to connect this directly to an Android phone to reduce lag, as it says it is supported by Android. But if you read a little ahead, you'll notice that it only works on tablet, so connecting it directly to a phone is out of the picture. However, we still can connect this microbit to a computer and send information to the headset with cloud variables. Because the microbits feel, and that it can also get rotation to some degree, I think that the microbit is what I want to use on native Scratch. Now, our final obstacle is adding controllers to modded Scratch. And as many of you know already, this is actually quite easy. TurboWarp already comes with a controller add-on, which maps controller inputs to keys. In theory, we can grab a Bluetooth controller and connect it directly to our phone. Unfortunately, I don't have a good Bluetooth controller on me, so I can't easily test this. But I do have some USB controllers I got a while ago.
But literally during editing this portion, It is not detecting my controller, so I'm pretty sure this just broke, which is kind of sad.
And we can use the cloud variable trick mentioned earlier to send input from our controller to our headset. And while I won't be incorporating this into my game, don't forget that there is an extension to get data provided by an actual VR headset and controllers. And that's it. After much work and battling Scratch's limits, we now have a proof of concept that we can make VR for both vanilla Scratch and modded Scratch, with headset rotation and controllers to some degree. And this concludes the second devlog. But we're still not done, as our goal is to make a VR game in Scratch. And now that we have rotation and controllers, we now need to make a VR game. So watch out for the next devlog where we... Wait a minute. Why am I deleting the platformer? Oh no!